5.6. Okay. So let's start off with what is it that I want you to fill in those blanks with. Okay. This is important. If the degree of the numerator polynomial is less than the degree of the denominator polynomial, I want you to know that that means your horizontal asymptote is on the x-axis. And what I want to refer you to is, I had you look at the graph of 1 over x. The graph of 1 over x had a horizontal asymptote at 0. I don't want to mention the vertical asymptote because that we looked at Friday as far as whatever makes the denominator 0. The horizontal asymptote is much more complicated to determine. This is our first step toward understanding how to find a horizontal asymptote. Because what I want you to look at is 1 over x is a polynomial that is degree 0 over a polynomial that is degree 1. And if I am heading to infinity, my horizontal asymptotes are asking when the x is extremely big as a positive number or as a negative number, what happens to this ratio? So if I plug in x equals 1,000,000 and then 1,000,000,000 and then 1,000,000,000,000, how small is 1 over x? So small it's heading to 0. If it's a negative number then, and it's big, then negative 1,000,000, negative 1,000,000,000, negative 1,000,000,000,000, do you see that 1 over those numbers is so small? It's a negative number, but it's near 0. The point is near 0. That's the only issue that I want you to take in. If the degree of your numerator is less than the degree of your denominator, you are dealing with a ratio that is heading to 0 if you plug in super large values of x, be them positive large or negative large. So that's our focus today, is just numerator is less degree than the denominator. We're going to take this a next step later, but right now that's the whole thing. Now, the x-intercepts, those are the values of x that make the numerator equal to 0. And we learned that last time. So the numerator is equal to 0 with our first example when x is equal to negative 1. Now understand that when you go to what makes the denominator 0, that changes to finding you where your vertical asymptotes are. And I want to really point out the difference here, because sometimes people get confused with the fact that you're going to do something very different to find your x-intercept versus your y-intercept. On top of that, it seems like you're doing almost the same thing to find your x-intercept and your vertical asymptote. You're just solving for one of the two polynomials being equal to 0. It's just when the numerator is 0, you get an x-intercept. If the denominator is 0, then you get, instead of the fraction heading to 0, it's heading to infinity, and it's a vertical asymptote. The y-intercept is found differently. You will just take x equals 0, plug it in, 0 plus 1, 0 minus 2, 0 plus 2, and then you get an answer. The horizontal asymptotes on all these problems are going to be 0. Because I'm only giving you problems where the numerator polynomial is less degree than the denominator polynomial. Now, the next thing I'm going to talk to you about is creating a sign line with the information. And this is going to make sense after I go through an example with you, so I'm just going to walk you through it and then talk about what we did. So we found that the numerator was 0 when x was -1. The vertical asymptotes are where the denominator is 0, 2, and -2. These three x values, you're going to mark down as if this were a number line. Now, normally on a number line, you're going to sit there and like write, here's 0, here's +1, -1, +2, -2. Don't worry about that. This is a number line just as if it were the x-axis, but you just need to put down 3 numbers in the proper order. If these are your 3 numbers, what is the proper order from left to right? And you guys know that the smallest of the 3 is -2. The next size up is -1. And then the largest of the 3 is +2. Just put them in an order. You're not worrying about how you space it. The spacing is irrelevant because what you're trying to do is figure out where the graph is located, whether it is located where above the x-axis or below the x-axis. That's what this is going to tell us. Now, here's what you can do. Pick a number, any number, less than -2. I like to go big. I'm going to choose -10. Most people will go small and pick -3. But you know, when you can go big, go big. If x is equal to -10, you do not need to calculate the function value. All you need to know is, does the function give me a positive or a negative number? That's it. So I want you to look at, you have 3, look at this as 3 factors. You've got a numerator factor and 2 denominator factors. -10 plus 1, do you see that's negative? It's -9. I don't care about the 9. I care that it's negative. -10 minus 2, that's a negative number. It's -12. I'm not bothering putting the 12, just the fact that it's negative. -10 plus 2 is -8. All I care about is the fact that it's negative. So if you have a negative number divided by a negative times a negative, what is the entire fraction? Negative or positive? Negative. You got it. Negative. Yeah. So if you look at this as basically 3 factors, then it's really an issue of, do you have an odd number of them being negative or an even number of them being negative? And that's it. You just need to know positive or negative. And the whole thing is negative. So when I come over here to my sign line, I'm going to put a negative in this space. And in a little bit, I'm going to tell you how we're going to transfer this information. Until then, pick a number in between -2 and -1. And you go, I don't want to. I know, that's how I feel. -1.5. But you don't need to calculate. You don't need to know the function value. You just need to think, if this was the number that I plugged into x, will the factor in parentheses be positive or negative? That's all you care about. No calculating. You don't even need a calculator. I'm getting rid of that to get it out of the way. All right, here we go. So negative 1.5 plus 1, positive or negative? Tell me. Positive or negative? That numerator.
Well, the numerator is negative.
There we go. Good. That's all I'm asking. Hold on. Don't give me the whole thing. Just, I want you to realize how little you need to do. Does everyone see negative 1.5 plus 1 is negative? Okay. X minus 2, if I plug in negative 1.5, is that positive or negative? Anybody? Negative 1.5 minus 2, not the number, just positive or negative? Negative. Times. And then, what about this last one? Negative 1.5 plus 2, positive or negative? That's all. Positive. So this is all you have to do. You don't need to calculate. You just need to figure out with your addition or subtraction of each of these three factors, is that addition or subtraction giving me a positive or a negative? Without needing to calculate. Now, altogether, this fraction comes out as, dun, 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 dun. Hand. Positive. And was that a question? The hand? Or an accidental hand? Uh-huh.
No, I understand.
Yes.
I'm a little confused. Maybe I just
Mm-hmm.
myself, but
Yeah, that happens to us all.
where did the positives come from?
So what you're doing is you are, after you put down on this number line the values of x that make the numerator or denominator 0, so there are 3 of those numbers, you put them in order on the number line, and this gives you 4 spaces. So I've got space number 1, and then space number 2, and then space number 3, and space number 4. Each of those are intervals of x where the graph exists either entirely above the x-axis or entirely below the x-axis. So what I'm going to do is I'm going to pick any number in that x interval and then figure out if with that number plugged into x, am I getting positive or negative for this fraction? And you don't need to know the number, just positive or negative. So if I put in negative 1.5, if I add 1 to negative 1.5, it's negative. If I subtract 2 from negative 1.5, it's negative. If I add 2 to negative 1.5, it is positive. And then if I, absolutely, and then 2 negatives and 1 positive, altogether, even number of negatives mean positive. So this is something you'll actually be able to do quickly if you understand that that really is all you need to do. It's a matter of getting to accept that, yes, that's it. Don't have to do any more than that. So pick a number between negative 1 and 2, and most people are going to pick 0. So I'm going to go back up to my fraction. I'm going to erase all this stuff. And I'm going to say if x is equal to 0, 0 plus 1, 0 minus 2, 0 plus 2. The numerator, 0 plus 1, is positive. Make sure you can see that's 0 for x. 0 minus 2 is negative. 0 plus 2 is positive. So the fraction overall, there's only one negative, so it is dun, 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 negative. I am so glad to have some in person. Oh my gosh. Trying to teach solely online is brutal. Having people to look at and have some somewhat interaction with. Oh, anyway. All right, now pick a number bigger than 2, any number. And I will tell you that on the two ends, I like to go big because I don't need to calculate. I just need to figure out positive or negative. So for me, I like to go with my tens because tens are really easy to calculate with. So I used negative 10 before, but now I need a big positive number, so I'm picking 10. And 10 plus 1, positive or negative? And if someone in class can just hold up, and go like that, that'll make me feel like you're with me here. And so you guys see it, right? 10 plus 1 is? Show. Well, doesn't even matter that it's 11, just positive, that's it. Okay? 10 minus 2, positive or negative? Show me. 10 minus 2 is positive. 10 plus 2, positive or negative?
Positive.
Boom. Thank you. Thank you. You guys just didn't feel like moving your hands. And then all together, positive. And I ask you, how quickly can you do that? Do you think you can do that quickly, maybe even without writing anything down? If you can do that without writing anything down, I'm perfectly okay with that. Now, what are you going to do with it? Well, first of all, let's draw in the information that we got originally. We originally found the y-intercept is negative 1/4. The x-intercept is negative 1, vertical asymptotes, and we got that the horizontal asymptote is 0 because we have degree 1 over degree 2. Less degree in the numerator means heading to 0 when it's big. I'm going to plot these. So I had vertical asymptote, horizontal asymptote. So I draw my asymptotes. Then my intercepts are negative 1 for x. And y is some horrible, awful negative 1/4, which I'm just going to approxiplot. Now, I want to show you the power of the number line. When I am dealing with the x interval less than negative 2, my graph exists entirely below the x-axis. My graph will only exist down here. My graph must follow the horizontal and vertical asymptotes. If I must follow this horizontal asymptote and I am stuck under the x-axis, do you see that it's coming from underneath? If I look right to left, then I'm under the graph coming up to that horizontal asymptote. If I am stuck under the x-axis on the left side of negative 2, I either have to go up the asymptote or down the asymptote. It's one or the other. The vertical asymptote has two sides, and each side I'm either heading up or down. If I'm stuck under the x-axis, there aren't any options. I'm heading down, period. End of story. Do you realize how much knowledge you have about the graph right at that point? Now, if you want more accuracy, you can make a table. I don't expect that. I expect you to understand that the graph has to connect between these two arrows I just drew, and it curves. So how do you connect it? Just kind of go, wee. And maybe that's not what you drew. Maybe you drew, wee. I don't care which one you draw. I just want you to get the idea that you have something that curves like this, that it must follow the asymptotes and be under the x-axis.
Miss Blanche, I have a question.
Yes.
How did you know the left end was like heading up and the right was heading down?
Okay, so with the horizontal asymptote over here, when you're dealing with these rational functions, every asymptote you draw has two ends. The horizontal asymptote has a left and a right end. On the horizontal asymptote's left end, it either has to come to it from underneath or from above. Those are your only two options. If you know that you only have negative values of the function, you know that it has to be from underneath, that you are heading to 0 from a negative number. Then with the vertical asymptotes, they have two sides, a left side and a right side. On the left side, it's either heading down or it's heading up. And you have to figure out which of those two it is. But if you know that you have only negative values of the function, then your only option is to head down. So what I'm hoping you'll be able to see is these asymptotes are super powerful. You must follow them. And you only have so many options. And if you combine some small pieces of information that are easy to deal with, you can know essentially what's going on with the graph. And so by combining just a few pieces of information, you know that this graph somehow exists in here doing this kind of a bend. And I also want you guys to understand, or you folks, I want you folks to understand that you are only needing to get to a certain point in this class with graphing these types of functions. If you go into your Intro to Calculus class, you're going to be taken to a next level. At this level, I just expect you to understand the location approximately and just that it curves. We're not going to get into weird fancy twirling curves. We're going to keep it super basic. Just understand how the asymptotes must be followed and the location. That's about it. Not perfect location, basic location. So that's that piece. We've still got a bit more to go. So the next thing that I want to look at is when I'm between x equals -2 and -1. It's not a very big section. -2 to -1, just right there. I'm positive I'm above the x-axis. Now, the vertical asymptote at -2 has a left side and a right side. We already looked at the left side. We are now able to look at the right side. And on the right side, It's either heading up or it's heading down. Because we know that the function must exist in the positive above the x-axis area, we know that it has to be heading up. So we took two options and figured out which one it was based on that positive negative chart that was made. Now, this tiny little section is going from a vertical asymptote to an x-intercept. So that's about all you need to know. Whee! Then I look at the next section. From -1 to +2, -1 to +2 on the x-axis is here. I have only negative values. That means I'm under the x-axis. Under the x-axis. Now, vertical asymptote at 2. That right there. That vertical asymptote has a left side and it has a right side. Right now, we can figure out the left side. The left side of that vertical asymptote, we're either heading down or we're heading up. Which one is it? Because we have to have only negative y values, we are heading down. Now, let's play connect the dots. If I'm stuck in this green region and I've got to go through, I know this point, I know this x-intercept, and I know that I'm heading down right here. Do you see that there aren't a lot of options and it's just basically like make it look curvy and good to go? Thank you. I'm going to finish this. So positive above the x-axis. So from 2 all the way down, I have to be above the x-axis. My vertical asymptote has a right side. I'm either going down it or I'm going up it. Because of the region I'm in, it must be up. My horizontal asymptote, I'm either coming from the positive side down to it or from the negative side up to it. Because I know where my region is, I know that my graph must do this. And all I want is a basic shape, and that's it. Just a basic shape. Now, I'm going to open... Yes. I'm going to open the formative, and I'm going to then continue what I'm talking about and keep recording. Okay, let me think. What? No, not that one. Go here, that one, and sign. Okay, I think it did it. There we go. Okay, and I'm going to post the link. Okay, so there's the link. You can get started on it. I got you through one of the classwork problems, but I'm going to keep talking, and I'm going to go through the next classwork problems more quickly. Oh boy, I wanted to get through a whole lot more, didn't I? I'm hoping that by slowly going through that first example, the other ones are going to make more sense as I go quickly. So if you're online You can mute me if you're here in class. You can't mute me, but you try to focus on the quiz, and you can look at this recording later. So here we go. I'm going to run through all of these examples quickly. X-intercept. X-intercept is what makes the numerator 0. 8 can never equal 0, so there are none. Y-intercept is found by plugging 0 into all the x's. When I plug 0 into all the x's, I get 8 over 0 minus 10. So 8 over negative 10 reduces to negative 4/5. Vertical asymptotes are what make the denominator 0, but I need to factor that. So I'm factoring x squared minus 3x minus 10. And then I'm looking at what makes that equal to 0. And that would be x equals 5 and negative 2. All the problems I'm giving you, the numerator is less degree than the denominator. Degree 0 over degree 2. Horizontal asymptote is 0, y equals 0. Every one of these problems, that's going to be your case. For creating the sign line, you're looking at what makes numerator or denominator equal to 0. Nothing makes the numerator 0. 5 and negative 2 make the denominator equal to 0. Between only those two numbers, put them in proper number line order. Negative 2 is smallest, 5 is largest. This creates 3 sections. One section, second section, third section. You need to know in each of those sections if the function is giving positive or negative. So pick any x in this interval as a test number. I like to use negative 10 for my left end if I can. I'm going back to my original function, and I actually would prefer to rewrite this in its factored form. So I have 8 over x minus 5 times x plus 2. Now, this numerator is just positive. It doesn't matter what x is. It is positive at all times. So I only need to figure out 2 things. If I plug into those only 2 x's, negative 10, negative 10 minus 5 is negative, negative 10 plus 2 is negative. Overall, my fraction has 2 negatives. It's positive. Doot, 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 doot. Positive. Then, section number 2, pick any number between negative 2 and 5. I'm going to choose 0. And then I'm coming back over here. And now, 0 minus 5 is negative. 0 plus 2 is positive, and that 8 is stuck at positive still. 1 negative overall, negative. And then pick any number larger than 5. I like to go with 10 because it's easy to calculate. I'm going to erase that and these two. With x being 10, 10 minus 5 is positive. 10 plus 2 is positive. Whole fraction is positive. Now, when I go to graph the function, I'm going to first put in my asymptotes. I have vertical asymptotes of 5 and negative 2. 5 and negative 2. My horizontal asymptote is 0. As far as x and y intercepts, I only have a y-intercept of negative 4/5. And let me tell you that if you don't have any x-intercepts, you absolutely cannot cross this horizontal line. You're on one side or the other side. Now what I'm going to do is I'm going to do a highlight of when x is less than -2, I have to have a positive y value. When x is between -2 and 5, I have a negative y value. When x is greater than 5, I have a positive y value. This tells me the location of my graph. Now I must follow the asymptotes. I must follow the horizontal asymptote. I must follow the vertical asymptote. Over here, I must follow the vertical asymptote on this side. I must go through this point. Somehow I have to come back down to go down this asymptote because I'm only negative in that region. And then this positive region. You can do it that quickly, but let me make sure to explain step by step why these choices were made. On the left side, the horizontal asymptote has two options. It comes from above or below, so it has to come from above because of the positive value that we figured out. My vertical asymptote has a left side and a right side, so I start with the left side. The left side, I either have to go up or down. Because I have to be positive, I have to head up, and I bring these two together.
Can I upload the work when I get home? Because I was thinking of work.
Yeah, that's
Also, I have
absolutely
a
fine.
question. Should I, like, ask you tomorrow? If you're so excited.
1 second. Back to play. Okay. So, horizontal asymptote had a left side. Vertical, and I dealt with that. Vertical asymptote, I think I just talked about the left side, and now we're moving on to the right side. The right side of the vertical asymptote, we're either heading up or down. Because we're negative in that section, we have to head down. Vertical asymptote 5 has a left side and a right side. On the left side, I'm either heading down or I'm heading up. Because I'm in the negative arena on the left side of 5, I have to head down. When you combine the fact that between -2 and 5, you have these arrows where they have to be heading down, you have this y-intercept, you just need to show me that you somehow nicely go through this point, but you have to come back down somewhere. Where? You don't need to know that. That's not what I'm worried about with Math 3. That will be a next step if you go on to the next math class. Right now, I just want you to understand why it graphs in the region it graphs in. Then, the right side of 5, I'm either going up or I'm going down. Because I'm above the x-axis in that section, I have to head up the asymptote. And then the horizontal asymptote has a right end. And on the right end, it's either above or below the asymptote. And it has to be coming in from above because it's positive y values. All you need to know is that the graph smoothly connects. Draw something. It could look like that. Just, it's got a curve. It's not a straight line. It curves with these arrows. Now, this next one, what I'm going to do is I'm going to look at when I factor it, I get x plus 4 times x minus 4 for my denominator. Now, my x-intercepts are anything that make the numerator equal to 0. That's 0. My y-intercept is what do I get when I plug 0 into x, and I'm getting negative 0 over 4 times negative 4. Well, that's 0. Vertical asymptote is anything that makes the denominator 0. This is where the factored form is easier. Looking at the factored form, I can see that negative 4 and positive 4 make the denominator 0. Those are my vertical asymptotes. For horizontal asymptote, recognize that you have degree 1 over degree 2. If it's less degree on top, horizontal asymptote is 0. Then you're going to make a sign line based on anything that makes the top or the bottom of that fraction 0. So that's going to be, did you need to ask me a question or anything? Okay. And I can pause the video if you have a question. Okay. And then, so the numerator is 0 at x equals 0. The denominator is 0 at negative 4 and positive 4. Put those in their proper order on the number line, 3 numbers. Negative 4 is smallest, 0 is next largest, 4 is the largest. This splits this into 4 sections. One section, second section, third section, fourth section. With each section, you're going to choose some number to plug in. On the left end, I like to go big with negative 10. On the right end, I like to go big with positive 10. A number between negative 4 and 0 is negative 1, but you can choose other numbers. Between 0 and 4 is positive 1. I'm sticking to 1s because they're easy to work with calculating. So negative 10, and I'm looking at the factored form, that is the easiest one to work with. I have one factor in the numerator, 2 factors in the denominator. If x is equal to negative 10, then negative 10 is positive. Negative 10 plus 4 is the negative, and negative 10 minus 4 is negative. Altogether, 2 negatives make positive. Next, I'm going to look at negative 1 for the x. So if x is equal to negative 1, negative 1 is positive. Negative 1 plus 4 is positive. Negative 1 minus 4 is negative. Only one negative out of all of them, the whole fraction is negative. Then I'm going to try positive 1 for my x. And I'm going to erase all the signs I came up with. And now positive 1. Negative 1 is negative. 1 plus 4, positive. 1 minus 4, negative. I have 2 negatives. I get a positive fraction when 2 negatives are multiply dividing positive. Then I plug in x equals 10. And I'm going to erase my signs. In the numerator, negative 10 is negative. 10 plus 4 is positive. 10 minus 4 is positive. One negative altogether. The fraction is negative. Now that sign line is going to tell me where things are located. I'm going to erase all this over here to keep that out of the way. But before I do that, I'm going to put my asymptotes in and my intercepts. My asymptotes are horizontal y equals 0, my vertical asymptotes are negative 4 and positive 4. My intercepts are just plain 0. So that means 0, 0 is 1 point, and it's the only point I know so far. Now I need to figure out the graph from here. I am above the x-axis when my x is less than -4. I am above the x-axis. I exist up here. Between -4 and 0 on the x-axis, I am under the x-axis with a negative y value. I only exist down here. Then, when x is between 0 and 4, I am positive above the x-axis. When x is between 0 and 4, I am only positive above the x-axis. And finally, when x is larger than 4, I am under the x-axis. So when x is larger than 4, I am under the x-axis only. Now, I'm going to start with there are two ends of a horizontal, a left end and a right end. On the left end, I'm either heading from above it or below it. Because I know that I'm above the x-axis, I know that the answer is, and I just erased that I am above it for sure. The horizontal asymptote on the right end, I am either above or below. Because I must exist under the x-axis, the below one wins, and the above one I need to get rid of. So that's horizontal asymptote, has a left end and a right end. On the left end, it's either above or below. On the right end, it's either above or below. Now, I have two vertical asymptotes. Vertical asymptote number 1, -4. It has a left side and a right side. For the left side, I am either heading up or down on the left side. And you can see that because I must exist only in the positive above the x-axis arena, I must be heading up, not down. So I know this. That vertical asymptote now has a right side. On the right side, I'm either heading up or I'm heading down. I can see that because I have negative y values there, that I am heading down. So down it is. That was asymptote number 1, vertical asymptote number 1. Vertical asymptote number 2 is +4. It has two sides. On the left side, I am either heading up or down. Because I must be above the x-axis in that region, I am heading up. The right side of the vertical asymptote, I am either heading up or down. Because I must be negative under the x-axis in that region, I am not heading up, I am heading down. And now I have looked at, on the horizontal asymptote, a left side and a right side. A left side and a right side. For each vertical asymptote, I have a left side and a right side. Other vertical asymptote, a left side and a right side. Now, from there is one point that I found, the origin. I just need to connect these together. So in my yellow section, I just have to connect these and curve somehow like that. In the blue highlighted section, I have to come up to this x-intercept. And then in the green section, from that x-intercept, I have to head up the asymptote. In the far right section, in the pink, about all I know is this much without plotting points. I don't expect you to plot points. I just expect you to know the approximate location of the graph. And that right there is good enough. Let me show you the answers. That's what they officially look like. But I'm not expecting perfection. I'm expecting that you know where your vertical asymptotes are, you know where your horizontal asymptote is, and you know where the exact graph exists, more like in quadrants. So I'm existing in this quadrant, and then I'm existing in this quadrant and this quadrant, and then this quadrant. And just have graphs that are in those sections. Now, I've got 2 more to take you through. So here we go. X-intercept is what makes the numerator 0. Y-intercept is what I get when I plug 0 in. 0 minus 6, 0, 0 minus 6. I get a y-intercept of positive 1. I'm going to factor my denominator before I go for vertical asymptotes. And it's going to factor with x minus 3, x plus 2. My vertical asymptotes are what make the denominator equal to 0, positive 3, negative 2. And now I want you to look at the degree of the 2 polynomials, degree 1 over a degree 2. If that numerator is less degree, your horizontal asymptote is 0. The next thing is create a sign line using the values of x that make the numerator or denominator 0. The numerator is equal to 0 when x is equal to 6. The denominator is 0 when x is equal to 3 or negative 2. I need to put those in a proper order. Spacing does not matter. Negative 2 is the smallest of the 3 numbers, 3 is the next largest, and 6 is the largest. This creates 1, 2, 3, 4 sections of the x-axis where you know whether you are above or below. I need to pick numbers. So I'm going to pick a number smaller than negative 2. I'm going to choose negative 10. I need to pick a number between negative 2 and 3. I'm going to choose 0. I need to pick a number between 3 and 6. I'm going to choose 4. I need to pick a number larger than 6. I'm going to use 10. And I've got it one at a time. Take a look. So negative 10 is first. If my x is equal to negative 10, I want to look at 1 factor in the numerator and 2 factors in the denominator. When I plug negative 10 into my numerator x, negative 10 minus 6 is negative. When I plug negative 10 into my first factor of the denominator, negative 10 minus 3 is negative. Negative 10 plus 2 is negative. If a function has 3 negatives multiplying or dividing, the whole fraction is negative. Then x equals 0. I'm going to erase the signs that I came up with. And when x is 0. 0 minus 6 is negative. 0 minus 3, negative. 0 plus 2, positive. If I have 2 negatives multiplying or dividing, overall fraction is positive. Positive. Now I'm going to try x equals 4. I'm going to erase the signs. And I just said that I was choosing, I forgot already, 4 for x. Okay, stop blinking my screen. Okay. Now, in the numerator, 4 minus 6 is negative. Denominator, factor number 1. 4 minus 3 is positive. 4 plus 2 is positive. 1 negative overall with multiplication division means a negative value will come out of that fraction. One more, x equals 10. So I've got 10 minus 6, positive. 10 minus 3, positive. 10 plus 2, positive. Everything is positive that's multiplying and dividing. Now, does it change positive, negative each time? Not always. We will see that exception to the rule in a moment. But I want to say that you can create this number line as quickly as long as you are using logical reasoning. Don't just guess that it goes positive, negative, unless you know why you can guess that. So, here we go. I'm going to first draw that I have a horizontal asymptote of 0. I have vertical asymptotes 3 and negative 2, 3, negative 2. I have an x-intercept of 6 and a y-intercept of 1. 6 for my x-intercept, 1 for my y-intercept. Now, using only this much information, I can bring in additionally that when x is less than negative 2, I am under the x-axis. If x is between negative 2 and 3, I am above the x-axis. If x is between 3 and 6, I am below the x-axis. And if x is greater than 6, I am above the x-axis. Now, my horizontal asymptote has two ends, a left end and a right end. Left end, right end. Then, vertical asymptote negative 2, right there, has a left side and a right side. Vertical asymptote of positive 3 has a left side and a right side. That takes care of my asymptotes. From here, I just need to draw something curvy between my known ends and points. So, connect. Not a perfect graph. That's okay. Over here, I've got to stay in this region. Do I know where my lowest point is? No. Does that matter? No. Not right now. It doesn't. Not for this class. Then stay in the region, hit the x-intercept, and then I've got something interesting. I've got to cross over here, but I've got to come back down somehow to hit that. Let's take a look at what that actually looks like. You can barely notice. Now I want to show you that on the left side of this horizontal asymptote, can you see that it is definitely under the x-axis? Now let's look at the right side. It crosses the x-axis at that x-intercept 6, but you can see that there's only so much that this is a Desmos application graph, and it's hard to tell whether this graph crosses the x-axis or just stays under it, because there's only so much our eyes can see unless we had zoomed in on this graph in a Desmos. If you want, type this function into Desmos and zoom in and see that it actually does cross the x-axis at 6, but it's still horizontal asymptotes. But how are you going to draw that? You're not going to draw that like perfect. So that right there, I accept the way you see that. It's not correct, but it is essentially expressing that it is above and then stays above. If you want to draw it like this instead, that's fine. I just want your graphs in the correct region as far as like these quadrants that I have highlighted, and then follow the asymptotes and have your x and y intercepts correctly drawn. Now I'm going to move to the last problem. The last problem adds in another little issue. Just going to get this out of the way so it doesn't distract. Okay, here we go. X-intercepts. What makes the numerator 0? X equals -7 and -2. Y-intercept. If I plug 0 into all the x's, I get 0 plus 7 times 0 plus 2 over 0 times, wait a minute, if I'm dividing by 0, then I do not have a y-intercept, because 0 times whatever in that denominator, I'm kind of getting 14 divided by 0. If I'm dividing by 0, no y-intercept. Now, vertical asymptotes are what makes the denominator equal to 0, and one of those is 0. If you have a vertical asymptote, x equals 0, you're not going to have a y-intercept, not with a rational function. Then the other factors are 5 makes the bottom 0 and -3 makes the bottom 0. Notice that you have 2 linear factors in the numerator. Numerator is degree 2. Denominator has an x squared that counts for 2 degrees of that polynomial, and another degree and another degree. It's a 4th degree polynomial. Second degree is less than 4th degree. You do have a horizontal asymptote of 0. Now I'm going to draw the asymptotes. I've got an asymptote y equals 0. And then vertical asymptotes of 0, 5, -3. 0, 5, and then -3. Now, I have x-intercepts, -7, -2, -7, -2. I have no y-intercepts, so as far as intercepts, that only gives me 2 points of the entire graph. Now, number line, the sign line. I need to look at what are the numbers that make the top and the bottom equal to 0 of this. That would be -7, -2, 0, 5, and -3. I need to put them in a proper order on a number line, but the spacing is not important. Smallest of these is -7, next -3, next -2, then 0, and then finally 5. Wow. This gives me 1, 2, 3, 4, 5. Actually, I probably shouldn't have used that. I just realized I need to use the highlighter version, which is, okay, there's not a nice, oh, there's my highlighter version. And then I need another highlighter color. Ooh, excellent, way too much. But this is the super hard problem of the classwork, designed to make sure that you've got everything, including the weird, crazy stuff. Each of these sections, I need to pick an X in the section. I'm going to choose -10 in my section less than -7. I'm going to choose X equals -4 for an X between -7 and -3. I'm going to choose to use -2.5 to be between -3 and -2. I'm going to choose to use -1 to be between -2 and 0. I'm going to choose X equals 1 between 0 and 5, and I'm going to choose a +10 for that last section. Now you're going to want me to go through this a little bit faster. So I'm going to grab, this is X plus 7, X plus 2, divided by X squared times 2 more factors. Those 2 more factors are -5 and +3. And I'm just going to sit here and go through this relatively quickly. All right. If X is equal to -10, then -10 plus 7 is a negative. -10 plus 2 is a negative, divided by -10 as a quantity squared is positive. If I square a number, I make it positive, times -10 minus 5 is negative, times -10 plus 3 is negative. All together, I have 4 negatives. That makes a positive. Next, I have X equals -4. -4 plus 7 is positive. -4 plus 2 is negative. -4 squared, hey, I'm squaring it. That forces it to be positive. -4 minus 5 is negative. -4 plus 3 is negative. I have 3 negatives altogether. 3 negatives between multiplication and division means negative. Next, I'm going to look at -2.5. Now, I'm not going to do any calculations. I'm just going to go -2.5 plus 7, positive. -2.5 plus 2, well, -2.5 is the bigger of the two between the negative and the positive, so negative wins. Now, I'm squaring this negative number. That forces it positive. -2.5 minus 5 is negative. -2.5 plus 3, just barely, it is positive. The 3 is bigger than the -2.5. I have 2 negatives overall. That means positive. Next, X equals -1. -1 plus 7, negative. -1 plus, hold on, reverse. -1 plus 7 is positive. -1 plus 2 is positive. -1 squared, forced positive. -1 minus 5, negative. -1 plus 3, positive. I only have 1 negative in that whole bunch. Negative it is. All right. I'm going to erase, and then I'm going to plug in a +1. Positive 1 plus 7, positive. Positive 1 plus 2, positive. Positive 1 squared, positive. Positive 1 minus 5, negative. Positive 1 plus 3, positive. 1 negative overall, negative. And finally, we see an issue where we don't get a sign change. Why did that happen? Because as I crossed over 0, that 0 factor came from x squared, because x squared is 0 when x is equal to 0. That squared issue forced this factor to be positive at all times. So when I went from -1 to +1, x by itself was supposed to change sign, but because it's squared, it won't go through a sign change. And everybody else stays as they are as I cross over that. So when you have a multiplicity of 2 or 4 or 6 or any even number multiplicity, you don't get a sign change for whatever makes that equal to 0. And that you can use to save your time heavily. Now, I'm going to do one last bit. When x is equal to 10, I get positive, 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 oh, positive, and oh, so positive. Now, I have to follow the horizontal asymptote on the left side. I am positive on the left side. I have to be following it here. I have to follow my horizontal asymptote on the right side. I am above the x-axis, so I have to follow it above the horizontal asymptote. For my vertical asymptote, I have a left side and a right side. The left side of -3 is showing negative. I must head down that asymptote. The right side of -3 is positive. I must head up that vertical asymptote. My second vertical asymptote is 5. With 5, I am negative on the left side. Okay, come on, pen. I am positive on the right side of 5. And so I have now identified 2 sides for each asymptote. And now I'm just going to stick within the regions of the positive, negative that were found. I'm going to do this quickly because I've got my next class coming in. I have to cross the asymptote and head down. Over here, I am forced up here, go through, and I didn't check my 0 asymptote, did I? For my 0 asymptote, I am negative and negative again. And then I don't know how high up I go. I'm not concerned about that in this class. I have to follow these asymptotes, and I've got to call it a day on this. Hopefully that helped. I can go over this more tomorrow. If that didn't make sense, good night and goodbye. Farewell. I will